Design a 4-bar Grashof crank rocker to give a 45 degrees of rocker rotation with equal time forward and back from a constant speed motor input. So let's start off with drawing and solving this example. So we pick our pencil and our rule. You see the distance wasn't given, so we should just design a 4-bar crank. The angle, only the angle was given, I get it. So we must find the distance for the output link. So let's stand over here. Pick this point, say here. Draw a straight line. We are told to measure angle 45. So pick our protractor. At the starting point, the line here, measure 45. So then from this point, you stand here, point to point, we draw. So this point O4, and this line is B, but we must decide the distance in which we want. Okay, so let's pick it to be 60 millimeters or 6 centimeters. So we pin at this point, draw an arc. The arc shows, the intersection shows the point B. So we have this to be the B1 and the B2. So after doing this, we draw what we call a chord, a straight line from B1 to B2. In synthesis, we make use of space. So then after drawing your chord, you pick your pair of compass. You bisect the line B1 and B2. So we step up B1, we put more than half. We arc B2, we arc. We pick our pencil and our rule. Please make sure the points meet, okay? So we now have this distance. We must select a convenient point O2 on the line B1 and B2 on this line, okay? B. How far the point O2 is, and it will help you to obey the Grashof law. The Grashof law. So how far O2 is from this B2, it helps obey the Grashof condition. So let's move it far apart, okay? So let's pin it over here. Let's say this point. So that point is our O2. So then we label the intersection point of the circle. But before we draw the circle, we must measure this distance. You see, they are equal. So this will be the radius for the circle at O2. So we label the point to be A1 and A2. But we are not done. We must measure that of the ground. That's from O4 to O2. We draw a straight line. Point to point. Draw a line. So at this point, we have this to be our ground. This is the rocker, this is the crank, and we have the coupler. Couple means two, so then linking the crank and that is the rocker over here. When the crank is at this point, it means the rocker is at its maximum point at this point. But if the crank is here, it means the rocker is now here. Rocker to rock and roll, to dance. So if it's here, it means the crank is here. If it's here, it means the crank is here. So we'll be measuring the ground, the crank, the coupler, and the rocker to see the distances. So to measure that of the ground, I'm taking the 20th point to be the 0 mark. So then you can use a rule from 0 to 10. So this 17, so I'm taking 20 to be 0, so then 17.4. The longest path is 17.4. Let's measure that of the crank. And the shortest point, the shortest length. That's 2.3 centimeters. Let's measure the coupler. So 10 being at 0 point. So 16 from here. Imagine 10 to be 0. So 16. 16.6. So the other length, that's not the shortest, not the longest, but the other point. So 16 point centimeters. And the rocker, we all measured it to be 6 centimeters. Have to be 6 centimeters. And to do that of the Grashof condition, there's always the smallest plus the longest must be less than or equal to the other two lengths. Let the smallest to be 2.3. The longest to be 17.4, which must be less than or equal to 16.6 plus 6. So by adding this, 19.7. Add it to 19.7, which must be less than or equal to 22.6. So 19.7 is less than 22.6 centimeters. So then this obeys the Grashof condition. But in case you are drawing and when the Grashof condition is not met, you clean the arc, this circle over here, you clean this line. So leave it, this vein and the line. Move the O2 to this point, move it further apart so that the distance of the coupler will increase. And then draw your circle, draw a ground again, and you measure until you meet the Grashof condition.